Have you ever stood up after sitting for hours and noticed something strange? Your legs feel heavier than they did that morning. Your ankles seem tighter. Maybe your shoes feel just a little more snug than they did when you first put them on. Then, almost without thinking, you start walking. Within a few minutes, that uncomfortable heaviness begins to fade. Most of us never question why. We simply assume that walking gets the blood flowing. It sounds reasonable. After all, movement is good for circulation. But if you stop and think about it for a moment, that explanation leaves behind a much bigger mystery. Your heart never stopped beating while you were sitting. It pumped roughly once every second. It sent blood through nearly 60,000 miles of blood vessels woven throughout your body. If your heart was doing its job the entire time, why did your legs feel different the moment you finally started moving? That question has fascinated physiologists for decades, and the answer reveals something extraordinary about the human body, something happening inside you every single day, whether you notice it or not. The truth is, your heart is powerful. In fact, it's one of the most remarkable pumps nature has ever created. Every minute, it sends blood carrying oxygen and nutrients to billions of cells, keeping every organ alive. Without that relentless rhythm, life would stop within minutes. But here's where the story takes an unexpected turn. As incredible as your heart is, it was never designed to work alone. That might sound surprising because we've been taught since childhood that the heart is the engine of circulation. Every diagram in school points to the chest. Every heartbeat reminds us that life depends on this remarkable muscle. Yet your circulatory system is far more collaborative than most people realize. Imagine trying to carry a bucket of water up several flights of stairs. Gravity fights you with every step. Now imagine trying to move blood from your feet all the way back to your heart while you're standing upright. The challenge is remarkably similar. Sending blood downward is relatively easy. Gravity actually helps. Bringing it back up is an entirely different problem. In fact, if your body relied only on the heart to pull blood back from your feet, standing for long periods would be far more difficult than it already is. Blood would tend to linger in the lower parts of your body, forcing your cardiovascular system to work much harder against gravity. So how did the human body solve this engineering problem? Not by building a bigger heart, not by creating stronger veins. Instead, evolution developed something far more elegant. It recruited your muscles. Every time you take a step, dozens of muscles quietly contract beneath your skin. Most people think these muscles exist only to move the body forward. They help you climb stairs, stand up, and keep your balance. But movement is only half their job. Hidden beneath those muscles lies another responsibility. One so important that vascular specialists often describe it as essential for healthy circulation while we're upright. The remarkable part is that most of us use this hidden system thousands of times every day without ever realizing it exists. Think about your last walk through a parking lot, your office hallway, or your neighborhood. You probably weren't thinking about blood vessels. You weren't thinking about pressure, gravity, or circulation. Yet with every single step, an invisible chain of events unfolded inside your legs. Muscles tightened, veins responded, tiny one-way valves opened and closed. Blood changed direction. All of this happened automatically, silently, and with astonishing precision. It's one of the most sophisticated mechanical systems in the human body, and most people have never even heard its name. But before we reveal what that system is, there's another question worth asking. If this hidden mechanism is so important, why do so many people experience tired legs after sitting all day? Why do long flights leave some people's ankles swollen? Why do cashiers, nurses, teachers, and office workers often describe their legs as feeling heavy by the evening, even if they haven't done any strenuous exercise? The answer isn't simply that they didn't move enough. The real explanation is far more interesting. It has everything to do with how the body moves blood when gravity refuses to cooperate. And once scientists began studying this hidden detail, they realized it influences much more than tired legs. It affects how efficiently blood returns to the heart, how pressure is distributed through the veins, and why something as ordinary as walking can support healthy circulation. But this raises an even bigger question. If every step activates this remarkable biological system, is every step equally effective? Or is there a way of walking that allows this hidden machinery to work closer to the way it was designed? To answer that, we first need to uncover the overlooked second pump Inside your body, a structure so important that many clinicians and educators have nicknamed it asterisk, the second heart, ask. And once you understand how it works, you'll never look at an ordinary walk the same way again. That hidden system begins in a place most people never think about. Not in your chest, not in your lungs, but deep inside your lower legs. If someone asked you to point to the most important muscle for healthy circulation, chances are you wouldn't point to your calf. Yet vascular physiologists have spent decades studying this very muscle because of the extraordinary role it plays every time you walk. In fact, many clinicians affectionately call it asterisk, the body's second heart. Asks, now that's not an official medical term, and your calf certainly doesn't replace your heart, but the nickname exists for a reason. It captures an elegant piece of biology that most of us experience thousands of times every day without ever noticing. Here's how it works. Threaded through the muscles of your calf are deep veins carrying blood that has already delivered oxygen to your tissues. Unlike arteries, which benefit from the force generated by every heartbeat, these veins face a much harder challenge. They must return blood upward against gravity, sometimes over a distance of nearly a meter from your feet back toward your heart. If blood simply flowed backward every time you stood still, circulation would become remarkably inefficient. So evolution developed a clever solution. Inside these veins are tiny one-way valves. Think of them as thousands of microscopic security gates. They allow blood to move upward, but once it has passed through, they close behind it, preventing gravity from pulling it back down. Of course, valves alone aren't enough. Blood still needs something to push it through those gates. That's where your calf muscles quietly take over. Every time your foot presses against the ground and your calf contracts, those muscles gently squeeze the veins running between them. That squeeze creates pressure, sending blood upward through the next valve. As the muscle relaxes, the vein refills, preparing for the next contraction. Contract, push, valve closes, relax, refill. Then the cycle begins again. It happens so effortlessly that you rarely notice it. Yet during an ordinary walk, this sequence repeats hundreds of times. Over the course of a normal day, it may happen thousands of times, creating a remarkably efficient partnership between your muscles, your veins, and your heart. This is one of the reasons movement feels so different from standing still. When you're standing without moving, gravity continuously encourages blood to settle in the veins of your lower legs. Your cardiovascular system compensates remarkably well, but over time, many people begin to notice heaviness, stiffness, or mild swelling, especially after long periods at a desk on an airplane or behind a checkout counter. The moment you begin walking, however, something changes. Your calf muscles wake up. With every step, they begin assisting the return journey of blood toward the heart. Research in vascular physiology has consistently shown that this muscle pump is one of the body's primary mechanisms for improving venous return while we're upright. Suddenly, those heavy legs don't seem quite so heavy anymore. But here's something even more fascinating. Moving blood isn't the only thing these muscle contractions accomplish. Imagine a quiet river that suddenly begins flowing faster after heavy rain. As the water moves more swiftly, it brushes against the riverbank with greater force. A similar event happens inside your blood vessels every time circulation increases. Blood doesn't simply travel through your arteries and veins. It gently glides along their inner walls. And those walls are anything but passive. For years, scientists believed blood vessels were little more than flexible plumbing. But research transformed that understanding completely. The inner lining of every healthy blood vessel, called the endothelium, constantly senses the movement of blood flowing across its surface. When blood begins moving more efficiently during physical activity, that delicate lining detects the increased flow. In response, it releases signaling molecules that help blood vessels function normally and adapt to changing demands. This discovery fundamentally changed cardiovascular medicine. It revealed that movement doesn't simply transport blood. Movement communicates with your blood vessels. That communication helps explain why regular walking has been associated with healthier vascular function over time. It's not because walking performs magic. It's because your body is designed to respond to movement in remarkably sophisticated ways. And that brings us back to the question we asked earlier. If every step activates this hidden partnership between muscles, veins, and blood vessels, could the quality of each step influence how effectively that system works? Many people assume that walking is simply a matter of putting one foot in front of the other. But biomechanics tells a more interesting story. The way your heel meets the ground, The way your ankle moves, the way your foot rolls forward, and the way your calf finishes each stride all influence which muscles are working and how much they're contributing. That doesn't mean there's one magical walking style capable of transforming your circulation overnight. Science doesn't support that claim, but it does suggest that efficient, natural walking mechanics allow the body to use its built-in circulation system the way it evolved to function. And once researchers started looking more closely at what happens inside blood vessels during those seemingly ordinary steps, they uncovered a tiny molecule that would eventually earn a Nobel Prize. Its effects reach from your legs to your heart and throughout your vascular system. The real surprise is that your next walk may already be activating it without you even realizing it. It begins with a sound so ordinary that most of us stop hearing it. A foot touches the ground, then another, and another. By the time you've walked from your front door to your car, your body has repeated this movement dozens of times without asking for your attention. It feels automatic, almost too simple to matter. But beneath that simplicity, an extraordinary mechanical system has already come to life. Every step sends a ripple through your muscles. Those muscles don't just move your bones, they briefly squeeze the deep veins hidden between them. For a fraction of a second, pressure inside those veins rises, gently encouraging blood to continue its journey back toward the heart. It happens so quickly that you'll never feel it. Yet without it, remaining upright for long periods would be far more difficult than most people imagine. Researchers who study vascular physiology have long recognized this mechanism as one of the body's primary solutions to gravity. Your heart generates the pressure needed to send blood throughout your body, but gravity constantly pulls blood towards your feet whenever you stand. The skeletal muscles of your legs, especially the calf muscles, help overcome that challenge by assisting venous return during movement. Think of it like an escalator. Your heart places passengers onto the journey, but the trip back from the lowest floor needs another system to keep everything moving in the right direction. Every calf contraction gives blood a small upward push, while tiny one-way valves prevent it from slipping backward. One push by itself isn't dramatic, but hundreds of pushes during a short walk become something remarkably effective. This partnership between muscles and veins explains an experience almost everyone has had. Imagine standing in a long airport security line. For the first few minutes, nothing feels unusual. But after 20 or 30 minutes, your legs may begin to feel heavier. Your feet become tired. Some people even notice mild swelling around their ankles. Then the line finally starts moving. Within a few minutes of walking, that heavy feeling often begins to ease. At first glance, it seems like nothing more than relief from standing still. But inside your legs, an entire biological system has quietly switched back on. That observation isn't just anecdotal. Clinical research has consistently shown that walking activates the calf muscle pump, improving venous return while you're moving. This is one reason walking is commonly recommended as part of conservative management for people with chronic venous insufficiency, alongside other treatments when appropriate. Notice something important though. This doesn't mean a 5-minute walk cures poor circulation. It doesn't mean every circulatory condition disappears with movement. And it certainly doesn't mean one special walking technique performs miracles. Science rarely works in absolutes. Instead, what the evidence shows is both more modest and, in many ways, more impressive. Your body already contains an elegant system for helping blood return toward the heart. Walking activates that system exactly as it evolved to do. The real question isn't whether the system exists. We've known that for decades. The more interesting question is how efficiently that system works under different conditions. Think about modern life for a moment. Our ancestors rarely remained motionless for hours at a time. They walked over uneven ground, climbed hills, carried food, gathered water, and changed direction constantly. Their leg muscles were repeatedly contracting throughout the day, naturally assisting circulation. Today, millions of people spend 8 or more hours sitting at desks, driving cars, or watching screens. From the perspective of your circulatory system, those two lifestyles couldn't be more different. Your muscles aren't broken. They're simply being asked to do less of the job they evolved to perform. That raises another fascinating question. If movement itself helps blood return toward the heart, could the way blood moves through your vessels trigger other biological responses as well? For decades, scientists assumed blood vessels were passive tubes, quietly carrying blood wherever the heart sent it. But they were about to discover something that completely changed cardiovascular medicine. The inside of every healthy blood vessel was listening, and what it heard would eventually lead to one of the most important discoveries in modern physiology. At first, that idea sounds almost impossible. How could a blood vessel listen? After all, it's just a tube carrying blood, isn't it? For much of the 20th century, that's exactly what scientists believed. Blood vessels were thought to be little more than passive, plumbing, flexible pipes that expanded and contracted when the heart demanded it. But the closer researchers looked, the stranger the story became. The inner surface of every healthy blood vessel is lined with an incredibly thin layer of cells called the endothelium. It's so thin that if you peeled it away, it would measure only a single cell in thickness. For years, almost no one paid much attention to it. Then researchers discovered something remarkable. Those tiny cells weren't passive at all. They were constantly sensing what was happening inside the vessel. Not the color of the blood, not its temperature, its movement. Imagine running your hand through a flowing stream. When the water moves slowly, you barely feel any pressure. But after heavy rain, the faster current presses more firmly against your skin. The water hasn't changed into something different. It has simply changed the force with which it flows. A similar phenomenon occurs inside your arteries. As blood moves along the vessel wall, it creates a gentle friction known as shear stress. Despite the name, this isn't harmful. In healthy amounts, it's one of the most important mechanical signals your cardiovascular system receives. Instead of ignoring that force, the endothelium responds to it. It's almost as if these cells are constantly asking a question: how is blood moving today? When movement increases during activities like walking, the answer changes. The flowing blood brushes against the vessel walls more consistently, and the endothelium responds by releasing chemical messengers that help the arteries adapt to changing demands. Among the most important of these messengers is a tiny molecule that transformed cardiovascular science. Its name is nitric oxide. Today, nitric oxide is recognized as one of the body's most important signaling molecules for vascular health. It helps blood vessels relax, supports healthy endothelial function, and allows circulation to adjust more efficiently during physical activity. The significance of this discovery was so profound that in 1998, the Nobel Prize in Physiology or Medicine was awarded to Robert F. Furchgott, Louis J. Ignoro, and Farid Murad for their work revealing nitric oxide's role as a signaling molecule in the cardiovascular system. That award wasn't given because nitric oxide was a miracle chemical. It was given because nitric oxide was a miracle chemical. It was given because scientists realized blood vessels were far more intelligent than anyone had imagined. Instead of acting like lifeless pipes, they constantly communicate with the blood flowing through them. This changes the way we think about movement. Walking isn't simply about burning calories. It isn't only about strengthening muscles. Every time you move, you're also creating mechanical signals that your cardiovascular system interprets and responds to. But here's where it's important to separate scientific evidence from internet myths. You may have heard claims that a particular walking technique can flood your body with nitric oxide in just a few minutes, or dramatically transform your circulation almost instantly. Those statements go far beyond what current evidence supports. Research clearly shows that physical activity, including walking, increases blood flow and supports healthy endothelial function over time. It also shows that regular exercise improves vascular health and contributes to long-term cardiovascular fitness. However, there is no strong evidence that one proprietary foot placement or one secret walking style uniquely produces dramatic nitric oxide release in healthy adults within 5 minutes. And that's actually good news, because it means your body doesn't require a secret technique to begin responding. It simply needs movement. Of course, the quality of your movement still matters. Walking with comfortable, natural mechanics allows your muscles and joints to work efficiently, while helping your body perform the tasks it evolved to perform. But the greatest benefit comes from consistency, not perfection. The remarkable story isn't that you've been walking the wrong way your entire life. The remarkable story is that your body has been quietly adapting to every walk you've ever taken. Yet there's still another piece of this puzzle that most people never hear about. Even if blood returns efficiently to the heart, even if your arteries respond beautifully to movement, there's another fluid traveling through your body that faces an even bigger challenge. Unlike blood, it doesn't have a heart to pump it at all. So how does it move? The answer reveals another hidden system that depends on every step you take. All writing, Variant equals document it equals 58194.E4. Number port 3A. The other circulation system you've never been taught about. If blood were the only fluid moving through your body, the story could end here. Your heart would pump. Your calf muscles would assist. Your veins would carry blood back home. Simple, but human biology is rarely that simple. Because while scientists were uncovering the hidden partnership between your heart, muscles, and blood vessels, they realized another circulation system had been quietly working alongside it all this time. A system just as important, yet far less understood. It's called the lymphatic system, and unlike your cardiovascular system, it has one remarkable difference. It has lymphatic system, and has one remarkable difference. It has no heart, HASC. Pause for a moment and think about that. Every day, tiny amounts of fluid leak out of your smallest blood vessels into the tissues surrounding your cells. This isn't a mistake. It's a normal part of how oxygen, nutrients, and hormones reach the places that need them most. But once those substances have been delivered, that extra fluid can't simply stay where it is. If it did, your tissues would gradually swell like a sponge left soaking in water. Instead, your body relies on a second network of vessels to collect that fluid, filter it through lymph nodes, and eventually return it to your bloodstream. That network is your lymphatic system. In many ways, it's the body's cleanup crew. It helps transport immune cells, remove cellular waste, carry certain dietary fats absorbed from the intestine, and maintain the delicate balance of fluid surrounding nearly every cell in your body. Without it, life would be impossible. But here's the mystery. If the lymphatic system doesn't have a powerful pump like the heart, what keeps the fluid moving? For years, that question puzzled scientists. Then they discovered something beautifully efficient. The lymphatic system borrows movement from everything around it. When you breathe, your chest expands and contracts, gently changing pressure inside your body. When nearby muscles tighten, they compress tiny lymphatic vessels. Even the natural movement of your joints creates small mechanical forces that help propel lymph forward. In other words, movement itself becomes the pump. And among all the muscles involved, the ones in your lower legs play an especially important role because they contract over and over again during walking. Think back to the airport line we imagined earlier. While you were standing still, it wasn't only blood that began moving more slowly. The mechanical forces helping lymph travel were also reduced. Then, as soon as you started walking, those forces returned. Your calf muscles contracted, your ankles flexed, your joints moved, and both circulation systems, blood and lymph, began working together again. This helps explain why many healthy people notice that prolonged sitting or standing can leave their legs feeling puffy or heavy, while a period of gentle walking often makes them feel more comfortable afterward. It's important to understand what the evidence actually says. Research supports that normal muscle contractions assist lymph movement and that regular physical activity contributes to healthy lymphatic function. However, walking is not compare for conditions such as lymphedema or other diseases affecting the lymphatic system. Those conditions require individualized medical evaluation and treatment. The real lesson is different. Your body evolved expecting movement to occur throughout the day. Which raises an uncomfortable question. What happens when movement almost disappears? Look around a modern office. One person has been answering emails for 3 hours. Another has spent the afternoon in video meetings. Someone else drove 45 minutes to work, sat through lunch, and will drive 45 minutes back home. By the end of the day, it's entirely possible to have spent 8, 10, or even 12 hours with surprisingly little lower body movement. From the outside, nothing seems wrong. But inside the body, a very different story is unfolding. The muscles that normally assist circulation remain largely quiet. The mechanical signals that blood vessels expect become less frequent. The rhythmic squeezing that helps both veins and lymphatic vessels becomes interrupted for long stretches of time. None of this means that sitting is inherently dangerous or that a few hours at a desk will suddenly damage your circulation. The human body is remarkably adaptable. The concern arises when prolonged inactivity becomes the pattern rather than the exception. This is why many health organizations recommend breaking up long periods of sitting with brief bouts of movement. Not because 5 minutes of walking is magical, but because your biology was designed for regular motion instead of continuous stillness. In a sense, the problem isn't that modern humans walk too little. It's that we stay motionless for far longer than our ancestors ever could have imagined. and that realization changes the question completely. Perhaps improving circulation isn't only about adding one perfect walk to your day. Perhaps it's about restoring the rhythm of movement your body has quietly depended on for thousands of years. But that idea creates another mystery. If regular walking supports both blood flow and lymphatic movement, why do so many myths still surround something as simple as putting one foot in front of the other? The answer reveals how easily good science can become oversimplified and why some of the most popular claims about walking don't tell the whole story. Writing. If there's one thing science has taught us, it's that the simplest ideas are often the easiest to misunderstand. Walking is a perfect example. Almost everyone agrees it's healthy. Doctors recommend it. Health organizations encourage it. Fitness experts praise it. Yet somewhere between scientific research and social media, many of the most important truths about walking became mixed with oversimplified advice and exaggerated claims. The result? Millions of people either underestimate what walking can do or expect it to do things that no scientific study has ever shown. So let's separate the myths from the evidence. The first myth is one you've probably heard your entire life. The heart pumps all of your blood by itself. It sounds logical. After all, the heart is the body's pump. But as we've discovered, that's only part of the story. Your heart creates the pressure that sends oxygen-rich blood throughout your body. Yet returning that blood from your feet while you're standing depends heavily on the assistance of your leg muscles, especially the calf muscle pump. Without those repeated muscle contractions, gravity would make the return journey much less efficient. In other words, your circulatory system isn't powered by one pump. It's powered by a remarkable partnership. Understanding that partnership changes the way we think about movement itself. But another myth is even more common. Walking is walking. Every step is exactly the same. At first glance, that seems reasonable. Whether you're walking through a park or across a parking lot, you're still putting one foot in front of the other. Yet biomechanics tells a more detailed story. Every step involves a coordinated sequence of movements. Your heel contacts the ground, your ankle moves through its natural range, your body passes over the foot, and your forefoot helps propel you into the next stride. Small differences in posture, stride length, joint mobility, footwear, fatigue, and even the surface beneath your feet influence how efficiently those movements occur. That doesn't mean there's one secret walking technique capable of transforming your circulation overnight. Current scientific evidence simply doesn't support that conclusion. What the evidence does support is that comfortable, natural walking mechanics allow your muscles, joints, and blood vessels to work together more effectively than stiff, restricted movement. Sometimes the truth is less dramatic than the headlines, but it's also far more useful. The next myth sounds surprisingly convincing. Only intense exercise improves circulation. If you've ever believed that, you're certainly not alone. High-intensity workouts do produce significant cardiovascular adaptations. They strengthen the heart, improve aerobic capacity, and increase fitness in ways moderate exercise cannot always match. But here's what many people overlook. Your circulatory system responds to movement across a wide range of intensities. Even moderate walking increases muscle activity, improves venous return while you're moving, and contributes to healthier blood vessel function over time. Large public health studies have consistently shown that regular walking is associated with lower risks of cardiovascular disease, especially when it becomes part of a long-term lifestyle rather than an occasional event. In other words, you don't have to finish every workout exhausted before your body begins responding. Consistency often matters more than intensity. That brings us to another surprisingly persistent belief. If I don't have pain, my circulation must be fine. Unfortunately, the human body doesn't always work that way. Many cardiovascular conditions develop gradually over years. Changes in blood vessel health, blood pressure, or vascular function often occur long before obvious symptoms appear. That's one reason routine medical care and risk factor management remain so important, particularly as we get older or if we have conditions such as diabetes, high blood pressure, or high cholesterol. Feeling well is encouraging, but prevention has always been more powerful than waiting for symptoms to appear. Perhaps the biggest misunderstanding of all, however, is this: more steps automatically mean better health. You've probably heard the famous number, 10,000 steps. It's become one of the most recognizable fitness goals in the world. Yet many people are surprised to learn that this number didn't originate as a biological threshold discovered by medical researchers. It became popular decades ago through a marketing campaign before later studies began investigating how different activity levels relate to health outcomes. Modern research paints a more nuanced picture. Health benefits begin well below 10,000 daily steps for many adults, although additional activity often provides further benefits. The ideal amount depends on age, overall health, physical ability, and lifestyle. The lesson isn't that step counts are useless. It's that numbers alone never tell the whole story. Quality of movement, regularity, and reducing long periods of inactivity all contribute to healthier circulation. When you put all of these myths together, a clearer picture begins to emerge. Walking isn't a miracle cure. It won't instantly reverse years of cardiovascular disease. It won't eliminate every cause of swollen legs, and it certainly doesn't replace medical treatment when disease is present. But dismissing walking as too simple to matter may be an even bigger mistake. Because every time you move, your muscles assist your veins. Your blood vessels respond to changing flow. Your lymphatic system receives the mechanical support it depends upon. Your cardiovascular system adapts, one step at a time. The remarkable part isn't that walking performs magic. The remarkable part is that your body has evolved to expect movement as part of its normal operating system. And once you understand that, another question naturally follows. If the science doesn't point toward one secret technique, then what kind of walking habits actually produce the greatest long-term benefits? More importantly, what small changes can almost anyone begin making today that are realistic, evidence-based, and supported by decades of research? That's where our journey leads next. After everything we've uncovered, one conclusion becomes impossible to ignore. Your heart isn't working alone. Your calf muscles are quietly assisting every step. Your blood vessels are constantly sensing movement. Your lymphatic system depends on muscle contractions, and together, these systems form one of the most remarkable biological partnerships in the human body. Which brings us to the question almost everyone is asking. So, what's the best way to walk? The internet loves simple answers. You'll find videos promising a secret foot position, a revolutionary stride, or a 5-minute walking trick that supposedly transforms your circulation overnight. It sounds exciting. But science tells a more practical and ultimately more empowering story. There isn't one universally perfect walking style that works for everyone. Your age, mobility, fitness level, joint health, and previous injuries all influence what feels natural and sustainable. The goal isn't to force your body into an artificial technique. The goal is to let it move efficiently. That begins with something surprisingly simple. Stand tall, not stiff, not like a soldier standing at attention. Instead, imagine a string gently lifting the top of your head toward the sky. Your shoulders stay relaxed, your eyes look forward rather than down, and your arms swing naturally beside your body. Why does this matter? Because posture influences how efficiently your muscles work. When your body is balanced, walking requires less unnecessary effort, allowing the muscles of your hips, legs, and calves to perform their roles more effectively. Next comes the stride. Many people assume that taking longer steps burns more calories or improves circulation. Not necessarily. An excessively long stride can increase stress on the joints and reduce the smooth rhythm that makes walking efficient. Instead, research in gait biomechanics generally supports a comfortable, natural stride, one that allows your foot to land close to your body's center of mass while maintaining a steady rhythm. Then pay attention to your feet. For most people, healthy walking follows a natural sequence. The heel gently contacts the ground. The foot rolls forward. Weight shifts smoothly across the midfoot. Finally, the toes help push the body into the next step. This rolling motion isn't something you need to exaggerate. It's simply the movement your body has evolved to perform. Every time your ankle moves through this natural range, your calf muscles contract and relax in a rhythmic pattern, helping activate the muscle pump we've been discussing throughout this documentary. And don't forget your arms. Many people barely move them while walking, especially when carrying a phone or keeping their hands in their pockets. Yet a natural arm swing helps balance the body, improves walking efficiency, and contributes to a smoother, more coordinated gait. It may seem like a small detail, but walking is the result of your entire body working together, not just your legs. Now let's answer another important question. How long should you walk? Here's where expectations matter. If you've spent most of the day sitting, even a short walk can reactivate the muscle pump and interrupt prolonged inactivity. But the greatest health benefits come from consistency rather than a single 5-minute session. Research from organizations such as the American Heart Association, the World Health Organization, and the U.S. Centers for Disease Control and Prevention consistently supports regular physical activity as part of a healthy lifestyle. For most adults, accumulating about 150 minutes of moderate intensity physical activity each week is associated with meaningful improvements in cardiovascular health. That doesn't mean every walk has to be 30 minutes long. Several shorter walks spread throughout the day can also help reduce long periods of uninterrupted sitting. Another evidence-based habit has attracted growing attention over the past decade: walking after meals. Multiple clinical studies have found that a 10 to 15-minute walk after eating can help reduce post-meal blood sugar spikes, particularly for people with prediabetes, insulin resistance, or type 2 diabetes. The explanation is surprisingly simple. As your muscles begin working, they use glucose for energy. This helps clear some of the sugar circulating in your bloodstream while also improving insulin sensitivity. It's a small habit, but over months and years, small habits often produce the biggest changes. Of course, walking also has its limits. If you experience persistent leg pain while walking, severe swelling, chest pain, unexplained shortness of breath, or wounds that won't heal, those symptoms deserve medical evaluation. Walking supports healthy circulation, but it is not a substitute for diagnosing or treating cardiovascular disease, peripheral artery disease, deep vein thrombosis, or other serious medical conditions. Knowing the difference between wellness advice and medical care is part of understanding the science honestly. And perhaps that's the biggest lesson this journey has taught us. We began with a simple question: how can just a few minutes of walking change your blood flow? The answer turned out to be both simpler and more extraordinary than most people expected. Walking doesn't perform miracles. It awakens systems that have been part of your biology all along. Every step activates the calf muscle pump. Every movement helps blood travel against gravity. Every contraction supports the return of lymphatic fluid. Every increase in healthy blood flow sends mechanical signals to the lining of your blood vessels, encouraging them to do what they were designed to do. None of these events happen in isolation. They're part of a beautifully coordinated conversation between your muscles, your veins, your arteries, your nervous system, and your heart. And perhaps that's the real surprise. Not that walking is magical, but that something so ordinary can trigger such an extraordinary chain of biological events. The next time you stand up after hours at your desk, the next time you walk through a park, or simply stroll to the corner store, remember that every step is doing far more than moving you from one place to another. Hidden beneath the surface, millions of cells are responding. Muscles are squeezing. Valves are opening. Blood is returning home. Signals are being exchanged. Your body is carrying out a masterpiece of engineering that has been refined over millions of years of evolution. And maybe that's the greatest health secret of all. Sometimes the most powerful medicine isn't found in a bottle or hidden inside a complicated fitness trend. Sometimes it's simply taking the next step.